हेलो फ्रेंड्स, कैसे हैं आप लोग। वंस अगेन वेलकम टू बैक माय चैनल निर्मल टेक्निकल एंड माय नेम इज निर्मल शंकर। होपफुली यू ऑल आर गुड एंड फाइन। आप लोग अच्छे होंगे। सो आई एम बैक with a new topic on Kubernetes. So before starting this session, I would like to say please like this video and subscribe my channel if you think you are learning something from my videos. If you can if you think that is good for you, so please like this video and subscribe my channel Nirmal Technical. So today our topic is about a resource in Kubernetes for a pod, a container. Okay, and I will also share with you resource and in resource request and limit. So what is resource? So what is resource in Kubernetes for a pod, a container? So friends, you remember when we create a pod, obviously then if you are going to create a pod, so we are going to create a container in that pod. Okay, so container also need a compute resources. A compute resources, friends, I think you all are very well known about compute resources. What is compute resources? Of course, compute resources, this is a RAM, CPU, hard disk. When you purchase any hard laptop or system in market, so of course you ask to that person that what is the configuration of this machine. Okay, so resource in the compute resources, this is uh, RAM. What is the RAM of that machine? What is the CPU of that machine? What is the hard disk and that machine? So in that way, uh, container is also, you know, you can say container is advanced level virtualization. Okay, you remember, if you remember in Docker, I have already shared with you that uh, container is a advanced level virtualization, OS level virtualization. Okay, so when you create a pod in con or create a pod, that means you are going to create a container. So if you do not specify the resource, so resource, this means CPU or RAM. So container have rights to use all the resources. That means all the availability of that node where it will create. That means in Kubernetes is a cluster setup, and cluster setup is a group of nodes, that worker node or master node. So if you do not specify that container need a this use of CPU, container need a this how much CPU, how much RAM, that means particular container. If you do not specify, so container will of course will create it, but container have rights to use of that all the resources available in that machine, in that node. So that container can use maximum CPU, maximum RAM of that available in this node. So this is the written here in this. This is the Kubernetes official website and the resource management for pod and container. So this is the definition is written is written it. This is written as when you specify a pod, you can optionally specify. You can optionally specify how much of each resource a container needs. The most common resources to specify are CPU and memory. They are the others. There are the others. So it is written. So what is the meaning of this definition? What is the written actually? If you set actually resource, how much resource you need a container. So when container will create, the container must be have that configuration. That means that a resource, that how much CPU, how much RAM, whatever you define in YAML file. Okay, so what does cube scheduler actually keep scheduler find which of the node is having such configuration is capable to have this configuration that kube scheduler assign this pod to that particular worker node. So this is the definition, and it is mentioned when you specify the resource request for container in a pod, the kube scheduler use this information to decide which node to place the pod on. That means which master node the pod should be created on that master node. Let's say a worker node having the configuration, having the resource availability, that worker node have resource available 2 GB RAM, only 2 CPU. But you want to create a pod 3 GB RAM and 3 CPU. So Cube scheduler cannot assign this pod to that worker node. I am giving an example to get understand. So Cube scheduler will search a node in a cluster who is having already this resource availability, that 3 GB RAM, 3 CPU, and then Cube scheduler will assign the newly created, and not exactly, I cannot say newly created, actually cube scheduler will design to be created that container to assign dot that worker node which is already having this resource availability, 3 GB RAM, 3 CPU. Then in resource management, request and limit. So request, when you create a pod, you set the request of that resource for a pod. So how much CPU, how much RAM need this container? That means when container will create, at least this resource availability should be. Then container create only. Then container can create only if this resource is available. And limit. So limit is that container can use maximum up to configuration this limit. That means if you set the limit 1 GB RAM, 1 CPU, so container can use maximum up to 1 GB RAM and 1 CPU availability on that node. If you container want to use more resource availability, more than 1 GB, more than 1 RAM, so pod will kill, pod will destroy. This is how resource, and question is that what is the use of this resource in Kubernetes? Actually, in real environment, in cluster there are many pods, there are many services on that individual pod, you can say individual container is running. And let's say a service which is running a pod A, and very important service in having a more load on a peak hour. Obvious, if there is a heavy load on that pod, so that pod will use more resources, more CPU, more RAM. So you want to define in advance when you want to create a pod using, when you want to create a pod, uh, there must be a more resource like more CPU, more RAM, because you know that this service, this service actually runs on a heavy load, heavy traffic in peak hour. So container will use maximum resource, maximum CPU, maximum RAM availability. So you should define the that this container limit, this container initial, how much CPU, how much RAM must be available for this container. This is how resource management for pod and container. For a better understanding, I am just giving an example to get understand. Like in buffet, in breakfast, if you are in a such hotel, there is no limit of that. You are in a hotel or restaurant in breakfast or dinner, like there is no limit, so you can eat whatever you want. But whatever you want, either you can take a bread 4 5. I'm just giving example here. Okay. But if there is a limit, there is a thousand, 100 rupees or 200 rupees thali, and you if you want to take a more than this, so you should pay. So there is a difference between both scenario, because in buffet you can eat max whatever you want, what you want to take, take, you can take. But in, if there is a limit set, if there is a limit set, that price of that thali, so This is how I about a resource management. And request and limit. So request, it is when you create a container, you set the request. That means it must be this configuration for a container when you are going to create. And limit, that container can use maximum up to configuration this limit. Okay. So better now I will share with you a lab. So it can be more understanding. It can be more visibility for you friends. So I have already installed the minikube on this cluster. So cube CTL get ports. Mm, one CTL. You can see in no resource found in defined namespace. So nodes. Yes, minikube ready control plane. Okay. So V1 the minikube version is V1.26.3. So let me share with you first example where I will set only the request, not limit. Okay. Kind is pod API version is V1. Metadata name is resource pod. Okay. Let me start name pod. Okay. Only pod tpod means test pod. Similarly, I will create a container also tc. Whatever you want, you can put here test container. Okay. So one more thing, let me tell you. Here is 200 m. So let me tell you. Don't worry. Okay. So CPU central processing unit. So it's the core unit. So one CPU is equal to 1000 milli CPU. One CPU is equal to 1000 milli CPU. And memory, so memory here I'm talking as a RAM. I'm talking for a RAM. Okay. So memory 100 mi, so 100 millibit. Okay. I mentioned here 100 mi, that means 100 millibit. Okay. So CPU is 200 m, that means 200 milli CPU, because I told you one CPU is equal to 1000 milli CPU. And memory is 100 millibit. So let me create a first pod where I request CPU 200 milli CPU and memory 100 millibit. Okay. So you can see I changed actually name that there's the reason behind that, because the resource I think you guys can confuse. Resource, this is the resources. Okay. I told you now in container you can set the resource request and limit as well. So resource that is what is the resource here? So resource is CPU, memory that means RAM, and CPU that central processor unit. Okay. So let me create a first pod. First let me create a file vi pod.yaml, paste, tube ctl, okay, cat, control L, cat pod.yaml. Okay, so actually I have actually this is simple. So okay, I will tell you also this one. So kind is pod. So I'm going to create a pod that's API version in V1. Metadata name. So I have set the pod name is tpod, and in specification, so containers, and container name is tc. Image what I'm using for image to create this container, nginx. Resources, so main today lab agenda is resources. So in resources, this is a CPU and memory where I have request where I request to Kubernetes, there should be at least 200 milli CPU and 100 millibit memory RAM for this container. Okay, moving forward. So cube ctl apply -f pod.yaml. I will also share with you limit as well. So you can see tpod is created. So cube ctl get pods container is creating. Okay, okay. Control L. You can see tpod is created where one container is running. So if you want to see, exactly that how much CPU and RAM is aligned for this container. So qctl describe pod tpod. Okay, less. So name is tpod, name is with default. This IP assigned to this pod and yes, you can see request that CPU is 200 milli-CPU and memory is 100 millibyte. Sorry. Okay. So control Z. Now let me share with you another example. This one, request and limit both, where I will share with you, showing with you both, taking both in resources that one is for request and one is for limit. So as I already shared with you what is request and what is limit. So request, that means what you tell to Kubernetes, at least this configuration should be assigned to this container. What we are going to create. A limit, that container can use maximum configuration up to this limit. So, okay, tube okay, vi pod1.yaml, press I on the system. I will change that name. No problem. If you want, you can put any name. So name here I put tpod1. Similarly, container name to tc1. Now you can see this is the request. That means this container at least should have this configuration: 200 milli CPU and memory, that means RAM 100 millibyte. Okay, and limit, that container can use maximum up to 400 milli CPU and 300 millibyte. So press W2 kubectl apply -f pod1.yaml. You can see this one is also container is creating under the pod test pod one. You can see now the container under test pod is also successfully running. So kubectl describe pod tpod1. Okay, less. So yes, you can see here. So in container, this is the container image nginx, that is the image ID, that is container ID, that is image ID, this is the port, this is the container ID, this is the image ID, this is the host port, state is running, started at 29th April. Okay, so here you can see CPU, that is the limit 400 milli CPU and memory, that means RAM 300 millibyte, and request 200 milli CPU and 100 millibyte. So request, in request, this is request that what you predefined for a container, that it should be must, it must be this configuration to attach this container, and that limit, that container can use maximum configuration up to this limit. More than limit container cannot use. So I guys, I think you have understand. a resource, what is the request, what is limit. So now let me share with you one example. If you think, if I set the value of resource more than which is available on node, okay, trying let me say one very interesting thing. Let's say the resource is available on a node is 1 GB RAM and 1 CPU, but I want to create a pod which need a let's say memory RAM 2 GB. Okay, so what happens? What will be? Guess. Okay, share with you. So firstly, let me share with you how much space is available on this mini cube cluster. That means a node. So this is the command. You can see 3.8 GI. It means 3.8 uh, RAM. Actually, okay. Let me show you too. Actually, this is a virtual machine which I have created on that Oracle VM VirtualBox Manager, and I have already set this 4 GB RAM and 4 CPU when I created this virtual machine on this Oracle VM VirtualBox using a Ubuntu server. Okay, that's why when I firing this command free -h, so it's showing 3.8. So now let me share with you. Let me share with you very interesting one example. If I set a limit of that container more than this resource, so what will be happen? Will cube scheduler will keep scheduler capable to create a container or not? Because this is the function of cube scheduler to assign the pod on a worker node. Okay, so I will create a pod where CPU is good but memory, that means RAM, is 5 GI, means 5 gigabit, 5 GBI, 5. Uh, okay, so VI pod 2.yml. What happens? Press I. Okay, VI pod 3.yml. You remember here I have actually defined that memory more than machine resource available, because machine I have set already only 4 GB, 4 GB RAM. Okay, but I in this for this container, for this code I have set the value 5 GB. So this is a more than machine availability. So you guys, you will see a very interesting thing here. Okay, so w2 cube ctl apply -f for 3.yml. You can see pod is created. Okay, pod is created. So let me the take the status of pod cube ctl get pods. Yes, you can see resource pod one, because on third YAML file the pod name is resource pod one and container name is resource one. Okay, image is same. But 0 by 1, what is the meaning of this? I remember that I said with you in that uh, previous sessions. Here is the example 1 by 1, that means one container under this content 1 by 1, that means one container is created which is successfully run 1 by 1. So one container which is successful, but 0 by 1, that is one container is created, but nothing is successfully running because the container status showing pending. So guess why this container went in pending status? Okay, let me show you. Qctl describe pod and this pod name. You can see here warning failed scheduling. But why? 0 by 1 nodes are available, one insufficient memory. This is the reason because the machine free hyphen h it is already having only 4 GB RAM configuration. But I have set the predefined in container creation of 5 GB. ls okay cat pod 3.yml. Yes, I actually set the memory 5 GB, but there is a space only 4 GB. So how can container create? No. So keep scheduler actually is unable to define, unable to schedule because the reason is that insufficient memory. So friends, now this is the our lab. What I shared with you. Resource, what is the resource, what is the limit, what is the request, and what is the actually use of in real environment. So real environment, as I told you, uh, we have to set that request a limit because in real environment there are many containers will run on that cluster, and some services which is running inside the container having a high load, high traffic. So we need to set previously when you want to create a container more resource for that container, and other container we will define less resource. So resource in the terms of CPU and RAM. So thank you all watching this video, and please subscribe my channel Nirmal Technical. Thank you. Bye bye.